Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. There are some problems in calculus about slope of tangent to the curve and their estimations. I hope that through these examples, your knowledge in calculus will be increased. So here we go. The graph of f is given. State with reasons the numbers at which f is not differentiable. F is not differentiable when the tangent to the curve is vertical or undefined slope. F is not differentiable when the slopes just to the left and just to the right of the point, even if it is continuous, are different. So that means it is a corner. F is not differentiable when a point is a point of discontinuity, that the slope just to the left and just to the right may be or may be equal or maybe not. But as long as they are not continuous, it is a point of discontinuity. So f is not differentiable also at those points. So those are the points which will make the function f not differentiable. So here is the given figure and the graduations, So at x equals -1, f is not differentiable because the tangent just to the left and just to the right is vertical. Secondly, it is also a corner point, right? But the tangent is vertical. That's the main reason. So at x equals -1, it is not differentiable because the tangent is vertical. At x equals 4, obviously there is a point of discontinuity. So therefore, x equals 4 is a point of discontinuity and the function f is not differentiable there. Then at x equals 8, it is a corner point. The slope just to the left, just to the right are unequal. So x equals 8. The reason is it is a corner point, so the slope just to the left is not equal to the slope just to the right. And finally, at x equals 11, the tangent is again vertical, so the slope is undefined or meaningless. So the tangent is vertical at x equals 11. We now proceed to the second problem. 2a, let f of x be cube root of x, then 2.a.1. If a is not equal to 0, find f prime a. Then 2.a.2, show that f prime at 0 does not exist. Then 2.a.3, show that y equals cube root of x as a vertical tangent line at 0, 0. So first, for 2.a.1, let us derive first f prime of x, then we substitute x equals a, where a is not equal to 0 for the first part. So we can transform this equation into f of x equals x to the 1/3, and the derivative f prime of x is by power formula 1/3 x to the 1/3 minus 1, so x to the -2/3 times derivative of x, which is 1. So it is just f prime of x is 1 over 3x to the positive 2/3. Replacing x by a, so f prime of a is equal to 1 over 3a to the 2/3. So that's 2.a.1. 2.a.2, we should show that f prime of x does not exist because at 0 because when x is 0, 1 over 3 times 0 to the 2/3, 0 to the 2/3 is still 0 times 3, it's still 0. So we have 1 over 0, division by 0 is undefined, therefore the slope of the tangent to the function at x equals 0, f prime of 0 does not exist. Then 2.A.3 show that y equals cube root of x as a vertical tangent at 0, 0. So that's the reason why at 2.A.2 the slope does not exist, because this 1 over 0 is infinity, meaning the tangent is vertical. So it is undefined, thus the curve y equals cube root of x has a vertical tangent line at 0, 0, because when we have 1 over 0, it's undefined. 0 just to the left, 0 just to the right, that's almost vertical line, positive or at x equals 0 we have positive or negative infinity, and that means that the tangent is vertical. And to sketch the graph of f of or y equals cube root of x, we have these representative values plus minus 27. Then when we have positive 27, cube root of 27 is 3, so we have positive 3. When negative 27, cube root of negative 27 is negative 3. Then positive 8, cube root of 8 is positive 2. Then cube root of negative 8, negative 2. Cube root of 1, positive 1 is 1, positive 1, and cube root of negative 1 is negative 1. And finally, we have when x is 0, y is 0. So connecting these points with a smooth curve, this is the graph of y equals cube root of x, and at x equals 0, obviously that tangent line is vertical. That's why it is not differentiable there. Problem 3.A, sketch the graph of f of x equals x times absolute value of x. Then for what values of x is f differentiable, and find a formula for f prime. So we know that absolute value of x is equal to x if x is greater or equal to 0, and it is negative x if x is less than 0. So we replace absolute value x by corresponding values here. For x is from negative infinity to 0, not including 0, so it is negative. So we replace absolute value x by negative x. So f of x is defined piecewise into x times negative x, so negative x squared for quantity negative infinity to 0, excluding 0. And when x is greater or equal to 0, x absolute value of x is x. So we have x times x, or x squared, which is for quantity 0, including 0 to positive infinity. These are parabolas, half parabolas. For this y f of x equals negative x squared, the graph is half parabola open downward. Then from negative infinity to 0, the tangent there is horizontal, almost horizontal. Then for x squared, the tangent there, this is a parabola that is open upward with vertex at 0, 0, open upward, and the tangent there is exactly horizontal when x is 0. So since the domain of f is negative infinity, union of 0, so we have negative infinity, 0, then excluding 0, union of including 0 to positive infinity. So that means 0 is included because of this other interval where it is defined. Therefore, the domain is from negative infinity to positive infinity. So that means the function x times absolute value of x is differentiable everywhere. So it is differentiable for all values of x. Then find a formula for f prime. Since f of x is defined piecewise by negative x squared for negative infinity to 0, excluding 0, and x squared for including 0 to positive infinity, we differentiate each. So it is equal to negative 2x for 0 for negative infinity to 0, and it is equal to 2x for 0 including 0 to positive infinity. So that means because for x is negative, the slope here is always positive for this interval, and this is always positive for this interval. Therefore, we can reduce this f prime of x to just 2x, 2 times absolute value of x. So this piecewise definition of f prime of x can now be made just one, and it is 2 times absolute value of x, because x is equal to negative 2 times x, and x is negative in this interval, so this becomes positive. This is always positive for this interval, so that's why we have 2 times absolute value of x, the formula for f prime. Then this is the graph, and this is the graph y f of x equals negative x squared from negative infinity to 0, and this is the graph of x squared from including 0 to positive infinity, or in short, this is the graph of y equals x times absolute value of x. Then recall that a function f is called even if f of negative x is equal to f of x for all x in its domain, and add if f of negative x is negative f of x for all such x. Prove each of the following. The derivative of an even function is an odd function, and the derivative of an odd function is an even function. So for 4a, if f of negative x is simply f of positive x, that means f is even. So therefore, if we differentiate f of negative x with respect to x, so we have f of negative x derivative, so it is equal to f prime of negative x times the derivative of negative x, which is negative 1. Therefore, f prime of derivative of f of negative x is the negative f prime of negative x. And it should be, because this is the original equation, if f is even, so the derivative of f of negative x should also be equal to the derivative of f of x. So the derivative of f of x is simply f prime of x. So that means negative f prime of negative x from this result. This is negative 1 times f prime of negative x, so that's negative f prime of negative x, and the right side is f prime of x. Since we can rewrite this as f prime of negative x is negative f prime of x, this shows that f prime is odd. So therefore, because the original equation here is f is even, the derivative of even function is an odd function, because the result here, f prime of negative x is negative f prime of positive x, or f prime of x. That means that f prime is odd. So from f equals even, the derivative is odd. So this is the conclusion. The derivative of an even function is an odd function. Likewise, if f of negative x is negative of f of x, that means that means f is odd. So if f of negative x is negative f of x, that means f is odd in this case. Therefore, the derivative of f of negative x is equal to the derivative of negative of f of x. So this derivative is f prime of negative x times negative 1, and the right side is negative of f prime of x. So simplifying, we cancel negative and negative here. So we have f prime of negative x equals f prime of positive x. So this means that f prime is even. Thus, the derivative of an odd function is an even function. We begin with an odd function, and we show that the derivatives of the left, which is f prime of negative x, is f prime of x. This shows that f prime is even. So that proves these two statements here. Then for the last exercise, let L be the tangent line to the parabola y equals x squared at the point 0, 0, 1, 1, and 2, 4. The angle of inclination of L is the angle alpha that L makes with the positive direction of the x-axis. Estimate alpha to the nearest degree based on the graph and the tangent line. And B. Compute alpha correct to 2 decimal places based on its derivative and compare to your estimates in part A. So for this 5A here, you're supposed to draw the tangent approximately, then you may fit a protractor and read the angle to the nearest degree. But I will not do that. I'll just determine approximately the rise and the run. Then tangent of alpha is rise over run, so that we can estimate to the nearest degree alpha. So we have to sketch the graph of y equals x squared. I think you're already familiar with this parabola open upward. Just you may have plus minus 2 for x, then you'll have 4 plus minus 1, and you will have 1, 0, 0, and you may include plus minus 3, then y is 9 to make the graph smooth and accurate. So let's have plus minus 2, negative 2, y is 4, positive 2, y is also 4, negative 1, y is 1, and positive 1, y is also 1. Then when x is 0, y is 0. So alpha O at 0, 0, because this is the lowest point, even if we estimate it, the tangent here is horizontal, and therefore it is really 0, horizontal, the slope is 0. So at alpha O, it is 0 degrees at 0, 0. This is the estimate for the tangent at point alpha 1 at 1, 1. This is alpha sub 2. The tangent here will be as shown. This is the approximate tangent. So we have the rise, which is from 1 to 3, so it's 2, but the run horizontal is more than 1 point, because this is 2.2, so we can estimate this as 2.02. Then this is 1 unit, so 1, this is 1, so 2.02 minus 1 is 1.02. So the rise is 2, the run is 1.02. So tangent of alpha 1 is 2 over 1.02. So alpha 1 to the nearest degree is 63 degrees at the point 1, 1. Likewise, at point 2, 4, the tangent is this, and this is approximated as 1, and this is 0.25 from the figure. So tangent of alpha 2 is 1 over 0.25, and 1 over 0.25 is 4. To the nearest degree is that alpha 2 is 76 degrees at 2, 4. Then you may use a protractor if you have an available protractor there, but the accuracy of the estimate of alphas will depend on the tangent you draw at these 2 points here. So for B, compute alpha correct to 2 decimal places based on its derivative and compared to your estimates in part A. So y is x squared, y prime, or the derivative is 2x, and y prime is also the tangent of the angle that it makes with the positive x axis or positive x direction. So tangent alpha is 2x. So at 0, 0, tangent of alpha O is 2 times 0. So 2 times 0 is 0, and alpha O is inverse tangent of 0. So that's why it is 0 degree. We have accurate same values of alpha O at 0, 0. Then at 1, 1, tangent of alpha 1 is 2 times 1, so alpha 1 is 63.43 degrees as compared to 63 degrees, so they are very, very close. Then at 2, 4, we have alpha 2. Tangent of alpha 2 is 2 times 2, x is 2. So alpha 2 is inverse tangent of 4, 75.96 degrees as compared to 76 degrees. So they are also very, very close.